Yeah, thank you very much. So thank you guys for being here. It's great to be back. So thanks to the BSides team for having me again. So today I'm going to talk to you about some personal research that I've worked on over the past year, which is in the field of OPSEC, or operational security. So this research has accumulated in the development of a tool, which is a hacking harness called Freedom Fighting Mode. Basically, I'm not sure if all of you are familiar with what a hacking harness is, and it's, even though the concept has been around for some time now, it hasn't seen too much development or research. So I think the best way to introduce it is to talk a little bit about the motivation behind the development of this tool, explain what it's trying to achieve, then show you, live hopefully, how it does, and then go back to more theoretical considerations. So the idea, the main concept is anti-forensics. So the idea is that sophisticated attackers will strive to limit the evidence they create on victim machines as much as they can. So, for instance, this can be IP addresses that could be used by the blue team for attribution. This can be tools, for instance, local privilege escalation exploits or backdoors rootkits, which shouldn't fall into the hands of the defenders because they may have some significant R&D or financial value. The attacker is also going to try and hide as much as they can what they're doing on the victim's machine, because it can betray what their final intent is, etc., etc. So there are basically two ways to achieve this kind of stealth, which is the first one, try and delete the evidence. And if you look at the equation group leak, for instance, you'll see that there are various tools that are trying to do exactly this. They have Toast, pclean, Dizzy, Tachometer, I think it's called, Dump Mode, etc., which are all various tools that try to perform secure deletion or log wiping one way or another. So I think it shows how important it is to these kinds of sophisticated attackers, how important it is to them to remove the evidence they create. The problem with this approach is that it's pretty hard. If you miss a single file when you're trying to delete the evidence, then you might as well have not erased it at all, because the defender only needs one entry in the log files. The other consideration is that possibly the logs are going to be uploaded in some remote enclave that you don't have access to, and when they are, then good luck deleting them, because this is not something you're going to be able to do. So the second approach, which by the way is not mutually exclusive with the first one, is to try and not create this evidence in the first place. So this happens through various techniques like executing as much thing as you can from memory, etc., etc., or not using the functions that are going to create entries in log files. So the reason I've been working a bit in this field is that I felt like red teamers should try to replicate APT procedures as much as they can in order to be able to see what the blue team would be able to actually see the day they are faced with a real sophisticated attack. The thing is, anti-forensics, as I've just said, is very error-prone, and there's this saying in InfoSec that the attackers have a real edge. And I think it's true until the point of the breach, because the attackers only have to find a single flaw in the defender's IT systems to be able to penetrate the network. But once they're in, I think it's also true that the attacker only needs a single mistake before they're found out. So this is a place where the blue team has a real edge in this fight. We also have, at least in the Linux world, a very we have a big problem with tooling. If you think about Windows exploitation, you have very advanced frameworks like PowerSploit or Empire, etc., which are very polished frameworks that allow you to do a lot of things and to perform lateral movement very easily. I don't believe we have such luck in the Linux world, so mostly people are going to be doing what the Grug is calling bareback hacking, which means you have a basic shell with no TTY, possibly received on a netcat handler, and depending on your conditions, you may be struggling to perform even very simple commands like ls or cd, because you have to deal with the absence of features on your terminal, like a no tab completion, the absence of arrow keys that would allow you to go back and forth on your combined buffer. There's going to be some latency issues. So if you are running your attack through a various number of proxies, then the time that is going to elapse between the moment where you press a key on your keyboard and the moment where it appears on the screen might be in the order of 10 seconds. So this is, in my opinion, a recipe for disaster. I think this is the best way you could imagine to help people type wrong things in the wrong terminal. So obviously, you could deploy an agent like Meterpreter or RevSH or maybe your custom backdoor. The problem is, I think deploying the agent kind of defeats the purpose, because if you're trying to leave as few traces as you can on the remote machine, then starting by uploading more tools from you is the wrong way to go, in my opinion. So, hacking harnesses is a concept that was developed to solve all these issues, and the concept was introduced by de Grugg in 2007 in the Hack in the Box presentation. He introduced his own tool, which was called Hash. It was lost for a long time. Even he had lost the source code, but it was found again. You can find it on GitHub now. But he hasn't worked on it for a while, I think. Basically, I highly recommend that you watch this talk, because he was right about everything, I think. And there was only one thing in which he turned out to be wrong, is when he said that we should expect to see a lot more development in this field in the future, because hacking harnesses are like a crucial part of post-exploitation. And it turned out that there wasn't so much research done after his own presentation. So without further ado, I'm going to try and show you how the hacking harness I've developed works and how it tries to solve all these issues. And to do this, I'm going to set up some fake exploitation scenario where I connect to a machine and with a simple netcat. So I don't have screen mirroring, so I'm going to have to look at the screen as I type. So please bear with my approximate typing, because it's something that I always struggle to do. Okay, so I'll still have connectivity, which is a good thing. So what I'm going to do is just have a netcat listener. Okay. And here below is going to be my attacker shell. Above, I'm connected to some VPS I own somewhere, and below is my attacker machine. For the beginning, I'm going just to perform a traditional pen testing, so with a simple netcat, and see how it goes. So hopefully, I'm going to receive a connection soon. Okay, there I am. So you will see that if I run some commands, they should work. Okay. Okay, you know what I'm going to do? I'm going to give up on the remote thing and try to do it locally, which is something I don't like to do, but come on. Okay, so final solution, I'm going to go back to the video. Of course, it's very small. I don't think anybody is going to be able to read this. Can you read this? No? Okay. Okay, it works now. Well, thank God for that. So, the idea here in a classic exploitation scenario is if I'm typing commands and I mistype, then I can go back. If I use the cursor keys, then things are I just get weird characters inside the shell. If I try to press Control A to go back to the beginning of the line, it's not going to work. If I press Tab to try to get some completion, it's not going to work. And at the end, I'm going to try to press Control C to clear the line and try again. And this is going to happen. I lose my shell, and I'm very frustrated. So let's try to do the same thing again, but except with the hacking harness on this time. And before I do, this is something that the harness is going to do for me. Is if I try to connect to a remote machine without first using one of those commands like torify, proxy change, etc., it's going to block the connection because it assumes that I'm making a mistake because I'm not using any anonymization protocol or tool. In this instance, I'm going to just bypass this check because I don't want to add Tor to the variance of this demonstration. Okay, so here I am. So now, if I try to type stuff, and if I use the keys, everything works fine. I can use all the usual command line, shenanigans that you would usually expect. There's another thing, which is I've implemented tab completion. So, for instance, there's here a script that's called torrent.sh. It's my personal box to download stuff. So here I get tab completion. So I think it's a very comfortable way to perform your post exploitation. But this isn't what the interest of the harness stops. Here I have implemented a list of commands that I can use. For instance, I think, something that's usually needed is to upload and download files to remote machines. But this is often a problem because if you want to send a file to the remote machine, one of the things you may end up doing is to post them to a third-party service, which may or may not respect the privacy of the files you send them. And in the case of a red team engagement, you may not want your backdoors to end up on VirusTotal the next day. So I've implemented a command that's going to allow me to upload and download files directly through the shell. I'm going to just download this torrent script that I just showed here and put it in /tmp. Come on. Yeah, so everything is going through the shell. I can do the same thing to upload files. And finally, I can also execute script in memory, which I think is the best part. So for instance, this is a script I wrote that performs log deletion. I'm not going to run it entirely, or maybe we can do it at the end if I have some time left. The idea is that I'm referencing a script that exists on my local machine, and it's going to be run on the remote machine entirely in memory. So the script is never going to touch the hard drive of the remote machine. It's just going to be executed. So there we go. So we have all the help. Okay, maybe I can launch it before I go on to this doesn't make sense. Let me see. Okay, so this IP address, I'm going to clean this one. Oh, by the way, yeah, if I press up and down, I also get the history of my commands, which I think is also useful. And there we go. So the log cleaning is going to take a few seconds. And there we are. And if I go back to the output of the last command, you'll see that this IP has entirely disappeared. So this is one of the things that the hacking harness is going to provide you. I'm going to show you just another thing. Oh yeah, this is something I forgot. If you press Control-C, it's going to ask you to confirm if there is a risk of you closing your terminal. then you'll have to press Ctrl-C again to make sure that you're not by accident going to be losing a connection that you need. I've also implemented a few things related to the SSH command. So if you try to SSH to a machine, for instance, this is going to be blocked because there is a risk of leaking my username. So if you connect to a machine without specifying your username, then the SSH command is going to send the current user. So which might be Ivan here, and which is something I might not want to be logged in on someone else's machine. So I have to explicitly put the username, and as well you'll see that there are a few options that are added to the command, like pubkey auth is equals no, because by default SSH is going to try all your local SSH keys on the remote machines, which can be used to identify you as well. And it's also going to add the -T flag automatically, which disable the remote allocation of a TTY. So basically, it's just an option that causes a lot of logs to be written everywhere on the system. So in case you forget to use it, it's going to be added automatically. Plus as well this safety net for people who tend to forget to use proxy chains, etc. So back to the presentation. So now that we've seen what the hacking harness in action, we can try and attempt to define what it is or what it should be. Basically, the first thing I think I should clarify is that absolutely everything is happening locally, which means that there is no agent deployed in the remote machine. Everything is just based on commands that are generated by my own shell. A question I get asked very often is, why not use a classic framework like Metapreter or RevSH, etc.? And the reason for this, to answer this properly, I think we have to go back to how a classical exploitation workflow goes. First, you find a vulnerability in some application. Then secondly, you exploit that vulnerability and get some form of remote code execution. Third, you send yourself a reverse shell, and finally, you persist and move laterally. The thing is, step 3, which is sending yourself a reverse shell, is incredibly more difficult than I think it should be. If you end up with a crappy www data shell, it's going to be very difficult for you to send files to the remote machine, and you're going to struggle. I know I've been struggling with it every time I've had to do something like this. So, if you really want to use the classical frameworks like Metasploit, etc., the hacking harness is still going to help you. It's very, very easy to write a hacking harness plugin that's going to start up the Metapreter shell for you, the handler, and then it's going to upload the Metapreter executable to remote machine executed, all in a single command, so you don't have to do it manually and struggle with it. So the idea is to provide basic TTY emulation, so all the tab completion, etc., and provide all the basic functionalities that you would expect. Of course, what I've demonstrated is by no means an indication of how people should work or what good OPSEC is. It's just a demonstration of the way a hacking harness could be set up. It works for me, but it's one of those types of tools that has to be customized to each person's personal way of doing things. So yeah, I guess the reason why it's called a hacking harness is because of the climbing analogy. The idea is that if you make a mistake while climbing, then if you fall down, and you're going to die. Whereas if you have a harness, then you might have a chance to survive. So I'm going to talk a little bit about the tool's internals now. So I'm not going to go into too much details of how the kernel works. Basically, we'll just assume that from the moment that you press a key to the moment where it arrives to your user-land application, magic happens, and it's not really important how it works. The way this framework works is it intercepts all the input and the output that is sent to the terminal. So usually there is something called in the kernel, there's something called a line discipline. I'm not sure if you guys are familiar with it. It's basically some line addition in a buffer. The idea is when you type some characters and you press backspace, then the application is not going to see the characters that have been typed. The characters are going to be deleted, and the application won't see them until you press enter. So this is something the line discipline does in the kernel. What I did is I put the terminal in row mode, which means that all this line discipline has been disabled, and I've re-implemented everything in Python, which means that every character every key press that comes from the user can be received by the framework and can be reinterpreted to reconstruct the command line. This is the reason why I'm able to have all this, cursor capabilities that the terminal shouldn't have. So this is what the line discipline looks like. I'm not going to spend too much time on it. It's basically a huge state machine. So it's not that interesting. I think what's more interesting is the fact that since all the command line is handled at the Python level, it allows me to do a lot of stuff like intercepting the command. So for instance, if I see an SSH command, I can block it, I can rewrite it, and then provide it to the underlying shell. This is the reason why, even though I was on a not so good Wi-Fi connection, I was able to have some decent. This is the reason why I was able to see what I was typing, is because everything I type is handled locally, and it's only when I press the enter key that the command line is sent to the remote shell. This means that if you go through 7 proxies, you're not going to suffer from the lag. It also means that you can forego PTY allocation on the remote machines because you just don't need it anymore. All the features are provided locally as well. So yeah, of course, if you see some interesting output from the commands that you generate, it's also possible to react to it, generate more commands, and really automate everything that's happening in your shell. So here's a quick list of the things that are implemented at the moment. Basically, I have the upload and download capabilities that I quickly shown earlier. The Python command that allows you to execute local Python scripts on the remote machine and everything in memory. I've got the exact same thing for bash scripts, plus a capability to spawn a PTY as well, which is useful when you have to type some passwords in a shell. This is something that's hard to avoid. One thing that I don't have at the moment, but I would really love to have, is the capability to execute local executables in memory as well, not just scripts. There is a project on GitHub called NetElf. I haven't had the time to look into it yet, but this is something I need to implement at some point in the future. When it comes to writing plugins, I'm not sure this is readable either, so I'll be quick. The idea is that I did my best to make sure that it's easy to customize the framework to your own needs. So this is even if you can't read, this is the whole Python plugin, the whole plugin that runs Python in memory. I think it's quite short, which is a good thing. The idea is that you don't need to understand everything that's happening in the shell to be able to write plugins. All you have to do is write methods that describe what the plugin does and to what types of inputs it should react. So for instance here, the plugin reacts to everything that starts with _py. And then you have an execute method in Python that's going to run Python code whenever this command line happens. So it should be pretty easy. In terms of compatibility, so I've tested this mostly on Debian flavors, and it works well, I think. I've had a few bug reports in the past where the harness can crash, not crash, but freeze. So if the harness is expecting some output and it hasn't detected that the remote shell is not sending any more output, then it's going to hang forever, which is not good. But I think most of these issues have been resolved. A problem that may arise is when some of the system tools that the framework expects are not present on the remote machines. So, for instance, all the upload and download functions are translated into ls or xsd od base64 commands, and if all those commands are not available, then they're just not going to work. piping and redirection are also expected. This may not look as much, but this is something that's a bit of a hard limitation for some scenarios. For instance, if you are using the harness through a Weavely, which is a PHP web shell, the harness is going to mostly work, and you'll get tab completion, which is very funny. But since the web shell doesn't support piping and redirection, you'll not be able to run Python scripts in memory, for instance. So that's that. So in conclusion, this is a framework that's open source. It's released under the terms of GPL v3, and it's written in Python 3 as well. You can find it on GitHub, and it's a little bit experimental, but I've been using it, and I've been able to transfer like hundreds of megabytes of files. So I think it's in workable condition. There are some features that are missing, like Control R to browse through the command history, which would be great, but I don't have at the moment. And I'm always looking for plugin IDs. So that's it, basically. If you have any questions, well, feel free to let me know, and otherwise, thank you for your attention.
Awesome tool, and glad that the demo went well at the end. Are there any questions in the room? Nobody? Not for now? Okay, you can talk to him later on. He will be here. He will be at the party as well, I think. Last year he was. It was fun. Okay, we'll see you for the next speaker in a couple of minutes. Thank you.